Hi, I'm going to talk today about preferences over lotteries. An utility representation of the expected utility form which we did yesterday. This is known as the VNM or von Neumann-Morgenstern utility function. There are some conditions regarding preferences under which the VNM representation is possible. Okay. The decision maker has a rational preference relation at least as good as on the set S, the set of all simple lotteries over the set of outcomes C. Now, axiom 1, some assumptions. The preference relation at least as good as on the space of simple lotteries S is complete and transitive. Now, what is completeness? A relationship at least as good as is said to be complete if and only if given any xy which belongs to X, either X is at least as good as Y or Y is at least as good as X or both. So you can either have just this being true or this is true or both are true. And a relationship at least as good as is said to be transitive if and only if given any X, Y, Z which belongs to the set X, X is at least as good as Y and Y is at least as good as Z implies that X is also at least as good as Z. Given any preference relation at least as good as the strict preference relation, this is a symbol of the strict preference relation, and it is defined by X is preferred to Y, which implies and is implied by the fact that X is at least as good as Y, but not Y is at least as good as X. That means only this is this is true. This is not happening here. This is not true. And the indifference relation, this is a symbol of indifference. It is defined by X is indifferent to Y, which implies and is implied by the fact that X is at least as good as Y, and Y is also at least as good as X. Hence, X is at least as good as Y means that the decision maker finds X at least as good as Y. X is preferred to Y means that the decision maker finds X strictly better than Y, and X is indifferent to Y means that this is the symbol. It means that the decision maker is indifferent between X and Y. Now we introduce some additional assumptions about the decision maker's preferences over lotteries. Okay, first additional axiom which I'll discuss here is the continuity axiom. The preference relation at least as good as on the set of simple lotteries S is continuous. If for any L, L prime, L double prime belongs to the set S, the sets alpha belongs to the closed interval from 0 to 1 such that the mixture of the two lotteries L and L prime with weights alpha and 1 minus alpha is at least as good as L double prime. It also is a proper subset of the closed interval 0 and 1. And another set is alpha belongs to the closed interval 0 and 1 such that alpha double prime is at least as good as alpha L plus 1 minus alpha L prime is also a proper subset of 0 and 1. And these two sets are closed. Okay. Now this alpha belongs to the closed interval 0 and 1. It means here this particular symbol or terminology, it means that alpha belongs to the closed interval from 0 to 1. Here the symbol written here means is a proper subset of in mathematics, meaning that if we write A is a proper subset of B, it means every element of A is in B, but A is not equal to B. So B might contain all elements of A and more. It might have more elements more than what is there in A, but every element of A will be in B. Here this particular set alpha belongs to closed interval 0 and 1 such that alpha L plus 1 minus alpha L prime is at least as good as L double prime, which is a proper subset of the closed interval 0 and 1. This particular term here means the set of all alpha between 0 and 1 for which the mixer alpha L plus 1 minus alpha L prime is at least as good as L double prime. So this particular mixer is at least as good as L double prime. That means it might be preferred to this L double prime, or it might be equally indifferent to L double prime, but it is not less than the mixer. This particular mixer is not less than this particular lottery L double prime. The set, this particular terminology here, it means the set of all alpha between 0 and 1 for which the mixer alpha L plus 1 minus alpha L prime is at least as good as L double prime is itself a subset of the interval, the closed interval 0 and 1. Okay, it is at least as good as means this particular mixer might be preferred to this lottery L double prime, or it might be indifferent to this lottery L double prime, but it is not less than this lottery L double prime. It is not less preferred to this one. So I hope you understand the meaning of at least as good as. The notation alpha L plus 1 minus alpha L prime means you mix lotteries L and L prime with probability alpha and 1 minus alpha. So this supposing that lottery L has two outcomes, winning $100 or getting just $0. You have 50% chance of winning this $100 and 50% chance of winning $0. Lottery L prime, you have 20% chance of winning $100 and 80% chance of winning $0. Now we mix them with the alpha as 0.4. So the mixer becomes 0.4 L plus 0.6 L prime, where 0.6 equal to 1 minus 0.4. Now this means that we have a 40% chance that we might end up with lottery L, or 60% chance that we might end up with lottery L prime. The final probability winning $100 is equal to this 0.4 into this 50% chance, or 0.4 into 0.5, plus this 0.6 into this 20% chance, or 0.2. So we have 0.32. The final probability winning $0 is equal to 0.4 into this 0.5 plus this 0.6 into this 0.8. And this is equal to 0.68. So the mixer itself is a new lottery $100 with probability 0.32 or $0 with probability 0.68. So the mixer itself is a new lottery $100 with probability 0.32 or $0 with probability 0.68. What does the continuity definition say? The preference relation at least as good as over simple lotteries is continuous if for all lotteries L, L prime, L double prime, the following two sets are closed. What is the first set? Alpha belongs to the closed interval 0 and 1, where alpha L plus 1 minus alpha L prime is at least as good as. Here this symbol should be at least as good as. Okay. Now, set A is a collection of probability weights alpha, where the decision maker still prefers a mixer of lottery L and lottery L prime over lottery double L prime. Okay, double prime, L double prime. The interpretation is that as we adjust alpha from 0 to 1, shifting toward L. So when alpha increases from 0 to 1, we are moving towards L. The point at which the mixer is better than L double prime should not suddenly jump. Preferences should change gradually as probability weights change. So we ask for which alpha the lottery L double prime is at least as good as the mixer of L and L prime. Again, as alpha changes, the reversal of preference should not be abrupt. It should not change abruptly. I'll just explain again. Why must these sets be closed? What is a closed set? A closed set includes all its boundary points, meaning there are no discontinuous jumps in preference. Example, suppose a slightly safer mixer suddenly becomes dramatically worse in preference. This would violate continuity. Supposing a mixer which you consider as not less risky and relatively safe, you suddenly dislike it. Your preferences change. It suddenly becomes, risky to you. Then your preferences are violating the assumption of continuity. So consider two lotteries, lottery L, which is a risky gamble, say with very large payoff, but some risk, okay? Now lottery L prime is a safer gamble where the payoff is small, but there is low risk. It's not very risky, okay? Whereas L is a risky gamble with higher payoff. This one is a safer gamble with less payoff. Now we consider mixtures alpha L plus 1 minus alpha L prime. When alpha is small, then you are more likely to end up with the safer lottery L prime, okay, when alpha is small, okay. When alpha is large, you are more likely to end up with a risky lottery L, okay. So, alpha is large, you might end up with a risky lottery. Alpha is small, you might end up with a safer lottery. Now imagine increasing alpha slowly. Let's say at alpha equal to 0.499, you prefer the mixer to some other lottery L double prime. Okay. When alpha increases slightly, the mixer is only very slightly. Remember, we said that the greater alpha is, the more you are going towards the risky lottery. Now, when alpha increases from 0.499 to 0.500, the mixer is only very slightly more risky. Alpha equal to 0.501, the mixer is still almost the same. A continuous preference means that if you like the mixer at alpha equal to 0.499, you should still like it at alpha equal to 0.50 or alpha equal to 0.501. Just a tiny increase in alpha should not suddenly flip your preference. Okay, the decision maker should not go from loving a gamble at 51% check success to hating it when this 51% success changes to 50.99999% success. Okay, the small changes in the values of alpha should not lead to sudden jumps in your preferences. This is the meaning of the continuity axiom. So now for a very simple interpretation which would be easy for you to understand. Suppose L is a beautiful trip by car, and L prime implies you stay at home. Okay. L means a beautiful trip by car, L prime means stay at home, L double prime means death by accident. If you prefer a beautiful trip by car to staying at home, then any small addition of death by accident risk should not instantly make the person prefer to stay at home. Supposing you prefer going on a car trip instead of staying at home. Then, so if you add another mixture, okay, to L, you add the probability of when you go on a trip by car, you add a certain probability of a risk of accident, okay. Then if you add this little risk of death by accident, even then, you still prefer to make the trip. You still prefer to make the trip instead of staying at home. So then any small addition of death by accident risk should not instantly make the person prefer staying home. As long as the probability of death is sufficiently small, they still prefer the trip. This example shows continuity. Preferences shift gradually with probability changes. That's all for today. Thank you.